Alright guys, so here's the review for your apportionment test. We're only going to have to find the SQ one time. The other times I'm going to give it to you. I've done the calculator work on the side, so you don't need to worry about doing that. But obviously we find our total population by adding them all up. And in this case we get 3,225. Let me put it to you this way, 3,225. We take that population, we divide it by 60, and we get 53.75. And that's how we get our standard divisor. Now I take that standard divisor and I divide each population by 53.75. So we get our total population, divide by the reps, and then take that number, which is a standard divisor of 53.75, and we divide it by each individual population. So in this case we get 5.08. We get 7.93. Let me make these numbers a little bit smaller so we're not taking up the whole screen. There we go. Okay, so with the next population we divide by 53.75. So 375 divided by 53.75, and we get 6.98. Then we get 3.65. Once again, dividing by 53.75, we get 13.04. We get 6.34, we get 1.66, and we get 15.33. So how did I get those numbers? I took my standard divisor and I divided each population by that 53.75. Now for my lower quota, I'm literally just taking the number in front of the decimal point each time. Let me make it so these numbers can be a little smaller. Okay, there we go. So 5, 7, 6, 3, 13, 6, 1, and 15. My upper quota, we just round up, so it's one more than the lower quota. 6, 7, I'm sorry, not 7, excuse me, that's a mistake, it should be 8, now 7, 4, 14, 7, 2, and 16. And now we want to add our lower quota up. So 5 and 7 is 12, and 6 is 18, 3 is 21, and 13 is 34, 34 and 6 is 40, 40 and 4 is 41, and 41 and 15 is 56. And a great way to check your work, add your upper quota up. 6 and 8 is 14, and 7 is 21, and 4 is 25, and 14 is 39, 39 and 7 is 46, 46 and 2 is 48, and 48 and 16 is 64. And there should be a difference of 8 since there's 8 candidates right here. So there's a good chance that I am right. Now my initial apportionment, I'm just copying my lower apportionment again. But the difference is the 4 biggest numbers after the decimal point get an extra vote. So while I'm just copying down out of the lower quota, I'm also taking the 4 candidates that do get the extra vote. And that's how I get to my final apportionment of 60. If you notice, 0.98 gets the first one, 0.93 gets the second one, 0.66 gets the third one, and 0.65 gets the fourth one. The 0.08, 0.34, the 0.08, the 0.04, excuse me, the 0.34, and the 0.33 do not get a vote. So my final apportionment should add up to 60. So we have 5 and 8 is 13. And 7 is 20. And 4 is 24. 24 and 13 is 37. 37 and 6 is 43. 43 and 2 is 45, and 45 and 15 adds up to 60. And that is my final apportionment for Hamilton's method. For the Jefferson method, if you've noticed, I've already gotten my total population, my reps, and my standard divisor of 63.09. And then I got my standard quotas, same way we did before, by taking each individual population and dividing by 63.09. Now, when I get my lower quota, I want to add that up. So I get 7, I get 11, 12, 9, 3, 14, 10, and 6. And when I get that total, 7 and 11 is 18, and 12 is 30, 39, 42, 42 and 14 is 56, 56 and 10 is 66, 66 and 6 is 72. That means I have 3 more reps to give away. I'm 3 below the amount of reps I have. Now, I want to give them to the numbers that are going to, when I get my modified standard quota, we're going to give those votes based on how the modified standard quota's lower quota is going to add up to 75. So essentially, I've got to get 3 of these standard quotas to move up so that the lower quotas add up to 75. Right now, the lower quotas add up to 72. I need to get 3 of these numbers to move. So I look for my likely candidates. 0.82 is a likely candidate. 0.60 is a likely candidate. These are bigger populations closer to the next number. The other 2 options are really 0.38 and 0.36. Now I'm going to move the 0.36 or the 14.36 up to 15, because even though 0.38 is a little closer, the bigger population moves much quicker. So what I want to do first here is I want to take my 14.36 and I want to make this standard quota 15.00. So my new standard quota would be 15. Or my new lower quota would be 15, excuse me. Now by doing that, I need to get a standard divisor that allows me to do that. So to get population F with 906 people, to get a standard quota of 15, we're going to do 906 divided by 15. And that leaves me with an answer of, let me put it in. This leaves me with an answer of 60.4. And that's going to be my new standard divisor. When I divide all the populations by 60.4 now, I get 7.55. I get 12.12. I get 13.39. I get 9.70. I get 3.53. I got my 15. I get 10.65. And I get 6.41. And now when I do my final apportionments, they're all lower quotas. 7 and 12 is 19. 19 and 13 is 32. 32 and 9 is 41. 41 and 3 is 44. 44 and 15 is 59. 59 and 10 is 69. And 69 and 6 is 75. So there is my final apportionment for my Jefferson method.